Good morning, everyone. Today is day 3. We're going to write and evaluate expressions today. So you're going to be taking words and turning them into expressions for equations. And you're going to be looking at equations and verbally expressing them. So, for instance, when you see addition, subtraction, multiplication, division, we're going to write some words that describe those actions. So if you have the word add, okay, there's other words that mean add as well. Can you think of any? Sum, increased, okay, things like that. Plus, I encourage you to pause the video and try to come up with ones for subtraction, multiplication, division. For subtraction, we say decrease. Sum, we'd say difference is the opposite of that. If you see add, subtract, maybe opposite of plus, minus. Okay. Multiplication, times. Multiply, twice, you see like 2 times. Division, divide. We see quotient. Quotient is the division of 2 things. So things like that. Those are just words to be aware of. So we're going to translate words into equations. And why would we want to do that? Because in life, you're not just necessarily given, besides in school, an equation and say, here you go, figure it out, that's your job, the end. A lot of times the problems we encounter in life are verbal, or we see them and we have to take those situations and turn those words for the situation into an equation to figure it out. So if I have twice the number n, well, twice is 2, and n's the number, so 2n. Okay, I encourage you to pause this again and try to do some of these. Half the number n. Half, when you say of, what's of mean? Of actually means multiplication of the number n. Do you have to put the parentheses? No. 2 less than a number. They don't mean this. If I said I was 2 years less than you, would I add 2 years to your age? Or would I remove 2 years from your age? If I'm 2 years less than you, I would subtract 2. So 2 less, you're moving the 2. 2 less than a number. The quotient is division. The quotient of a number and 2. So let's go back to this one, the less than. We can say that's part of subtraction. So then you could also say greater than would be plus. They're not meaning in comparison to numbers on the number line. So it's kind of tricky and you gotta just think about it. 4 times the quantity, 3 greater than a number. You could have written it 4 times the quantity, 3 greater than a number as well. You can distribute or leave it like this. These were just expressions. They weren't equations. We weren't solving for anything. It says you try. So now pause the video and you're going to try it. 3 times a number plus 5. 12 less than the quantity 4 times a number. 12 less in comparison to or than the quantity of 4 times a number. You could just write 4n minus 12. That's fine too. 8 less than half a number. 8 less than half a number. They're missing the word of. Half of a number. 3 less than 3 less than twice a number. Half the difference of a number and 1. That one's pretty tricky. Half the difference, so the difference, subtraction of 2 things of a number and 1. All right, we're gonna work on this a lot throughout the year. This seems to be pretty tricky. All right, let's go to the next page. So not only are we going to focus on words, but the orders of operations. It says, suppose, why do we need them? Suppose 2 classes are going on a field trip to the zoo. There are 20 people in one class and 22 people in the other. The teacher wants to order lunch for all the students. And in each lunch, there wants to be 2 packages of crackers. How many packages of crackers should the teacher order? Well, here is where the order of operations comes in. There's 2 packages per student. There's 28 in one class and 22 in the other. So the teacher will multiply 2 crackers per student. How many students do we have total? Well, we have 28 students and 22 students, so we have a total of 50 students. So 50 students times 2 packages of crackers each is 100 crackers. We need to use the order of operations to solve. The teacher wanted the order to be 2 times that quantity. If the teacher didn't use the order of operations, then instead of ending up with 100 packages of crackers, she would have done this. If she wouldn't have added these 2 first, and she just would have written it like this, she would have multiplied 28 by 2 to have gotten 56, and then added 22. She would have just got 78. Some kids would have been very unhappy. So orders of operations, these parentheses are saying, hey, do these first. So there has to be an order when we're simplifying or solving in mathematics. And that's the order of operations. So if you complete a problem left to right, that's very different than doing the orders of operations. If we went left to right, we would have gotten 9 times 7, which is 63. You would think this is how you go about evaluating the expression, but it's not. The algebraic order of operations is a 4-step process. You perform all the operations with inclusion symbols or parentheses. So that could be parentheses, that could be brackets, okay? It says perform all operations with exponents next, perform all operations with multiplication and division from left to right, and then lastly, perform addition and subtraction from left to right. You might have done this before, and there's an acronym for this, PEMDAS. Okay, so there's parentheses, there's exponents, there's multiplication and division, whichever comes first, and then there's addition and subtraction. Now, try the equation at the top again using the order of operations. What comes first? Addition or subtraction or multiplication, division? Well, multiplication comes first, so 3 times 7 is 21, and then you'd get 27. Well, we said 63, and now we're saying 27. Is there any difference? Yes, there is. A big one. So you got to use the order of operations when you are simplifying expressions. Okay, this is just a review, if it's in your packet, I believe it's in your packet, of natural being a part of whole, being a part of integers, and being rational. So that was your lesson for today, but I just want to go back and reiterate what numbers go where. So let's close also with put the following numbers in the appropriate boxes. Well, -8, it is rational, and it is an integer, but it's not a whole number. 25 is a natural number, so it goes in natural because it's a higher most. 6.8 is rational, but it's not an integer. Square root of 2 is not rational, so it's irrational. 5 1/3 Well, it's rational because it's a fraction, but it's not an integer. Negative 1.6 repeating. Well, that's rational because 0.6 repeating is a non-terminating decimal, which makes that a fraction. 3/11 is rational, but it's not an integer. Negative square root of 25 is -5, so that's rational. It's an integer. It is a whole number. No, it's not. And then 0/5. Well, I shouldn't have made that -5. I should have made that negative square root of 25. 0/5 is 0, so that is whole. And 3 pi is never ends, so it's irrational. So that was just a little review. We might have hit this in class as like a bell ringer or a checking for understanding, but some of you might not have, so here's a spot to fill it out. So let's do a checking for understanding now with PEMDAS and translating phrases, okay? We did a checking for understanding by doing the you try with the translation, but let's try one with PEMDAS here. I want you to try these two at the top. So just flip to this page, or you can write on a scrap sheet or wherever, and I want you to try, let's try 3 squared times 5 minus 6 times 4x. And let's try 3 plus 5 times 4 minus 2 all over 5 minus 1. Okay, I'm gonna pause the video. Go ahead and try it. So parentheses come first, so I'm gonna make that -1, but I also know my next step is to do exponents. I'm gonna multiply -4, and then you multiply again, you're gonna get -36. Over here, the stuff on top is considered to be in parentheses, and the stuff on the bottom is considered to be in parentheses. So it's gonna be 4 on the bottom. Up top, you're gonna have 3 plus, multiplication comes next, 20 minus 2, and then you go in order from left to right. So it's gonna be 23 minus 2 over 4, 21 over 4, and you can just leave it like that, okay? You're gonna have 8 problems in your book tonight. Some is on translating, some is on simplifying with orders of operations.